For the next problem, we're going to look at the what is the equilibrium constant for the following reaction, okay, at 25 degrees Celsius, given Fe2 plus 2 silver producing Fe plus 2 silver ion. So if we're going to look at the problem here, we base it on the given reaction. So based on this one, the one that is happening, okay, in your anode, which is the oxidation, would be your silver producing 2 silver ions, okay? And we could say the 2 electrons that we have there. So the one that is happening in the cathode is the one that is reduction. So you have Fe2 plus 2 electrons producing Fe. Now, we need to know the reduction potential for each of them, okay? So for the reduction potential of Fe2 plus to produce Fe plus 2 electrons, that is equals to, if we're not mistaken, 0.44 negative. Now, on the other hand, for the silver ion plus an electron to produce silver, that is equals to 0.80. So this is the one that is happening in the anode, and this is the one that is happening in the cathode. So if we're going to look at the formula, cell potential is just equals to the one that is happening in the cathode minus the one that is happening in the anode. So we're not going to change the sign because we took it as what we call the reduction potential. And all we need to do is identify which happens in the cathode and which happens in the anode. So the one that happens in the cathode is this one, the iron. So we're going to put there the 0.44. Okay, then we subtract it with the one that we have as 0.80. So giving us a cell potential that is equals to negative 1.24 volts. Now, as we could see here, this is non-spontaneous. So that means your K value is so small. So if we're going to look at the formula that we're going to use here, so the cell potential that we have here is just equals to 0.0257 volts divided by An. That's the number of the electrons involved, giving you ln of K. And if you rearrange this one, okay, you will have ln of K equals to the cell potential times N over 0.0257. And since we want to get the K, so we just get the E of this value that we have here. So we can replace it with the given value. So E cell that you have there, so that's equals to negative 1.24. Okay. And then N is 2 moles of electron. Okay. Divided by 0.0257. So if you're going to get the value of that and raise it to the E, so you have here a negative, so you're going to get a negative value. So if you're going to get that, you will end up with 1.23 times 10 to the negative 42. So this is indeed a very small number, less than 1. That's the prediction that we have. Okay.